Hello everyone, we're going to look at the large data set. Here is a sheet, and everything that we fill in on the sheet you do need to know. So let's begin. The large data set, firstly, what is it? Well, it's a big Excel spreadsheet with loads of weather information on it, okay? So, what months is it? May to October. What years is it? It's 2 years, 1987 and 2015. Moving over to this box, which days have only 30 days? Well, that's June and September. Moving now onto my map, I'm going to fill in some towns and cities locations. So, firstly, we've got Camborne, which is over here. Next, we have Herne. Then we have Leuchars. Next, Heathrow, which probably is the only one you've actually heard of. And finally, Leeming. Why have I done Leeming and Heathrow in blue colours? Because these two are inland, okay? So let me add this to my non-coastal list. Okay, so Heathrow and Leeming are inland, so they're not coastal. Why do we care about coastal stuff? At the coast, the temperatures are lower, the wind speeds are higher. Okay, so this is something you often need to mention in a question when identifying a town from some data. Remember, Heathrow and Leeming are not coastal. Moving on to the international stuff, we've got Jacksonville, which is also coastal. Then we have Perth down in Australia, also coastal. And finally, Beijing in China, which is not coastal, it's inland. So let me add that to my not coastal list. So how many cities and towns do we have? We've got 5 in the UK and we've got 3 internationally, so 8 in total. A couple of other little comments I want to make. The fact that our months are May to October brings about another comment. Sometimes you'll be asked, is an average or the mean of a load of data from May to October a good representation of the whole year? Well, the answer is no, because it's only 6 months. So this data is missing 6 months. So in terms of being a good average for a whole year, the answer is no. We would need to have data from all of the months, not just 6 months. Another thing I want to mention is Perth. It's winter during June to August in Perth because it's below the equator. So it's going to be colder in these months. Okay, don't forget that. Finally, looking at our international map, the equator is somewhere here. And this is important to know because the closer we are to the equator, the hotter we get. So you can see here's the UK. So both Jacksonville and Beijing, they're closer to the equator. So they're going to be hotter places. Now let's talk about some of our data. So there are 9 pieces of data and we need to have a little bit of a vague understanding of each one of these. Firstly, we have daily mean temperature. The units are in degrees C, and if you see NA, it means not available. So you have to be careful. Some slots have this in them because the data isn't available for them. In fact, this is something that comes up time and time again, so I'm just going to put this in the notes column for all of them. You see NA, it means not available. Be careful. If I'm taking a random sample, then I might pick one of these NA bits of data, which obviously I'm not going to be able to use. So this is a bit of a drawback of a random sample, and we might need to just bear this in mind. So maybe you'd make a rule that if I pick one of these, then I'm going to replace it with another piece of data. Next up is daily total rainfall. The units is millimeters. Couple of things to note here. This includes melted snow. So if you had snow that day and then it melts, then this will be part of the rainfall total. Also, we have this value called TR, which stands for trace. And that means that we have less than 0.05 millimeters. So we can kind of assume that this is just 0. If there's something that's got trace in it, when we're taking a sample, we're going to need to clean the data because we can't do calculations on a TR. That's not a number, is it? So we need to change this to 0. Next up is daily total sunshine. This is in hours, so this is the number of hours per day that the sun is breaking through the clouds, that it would cast a shadow. There's not much to say here, but except to say there's hours to 1 decimal place. The other thing to say with total daily sunshine is if you've got lots of sunshine, that's going to mean low cloud cover, isn't it? This hopefully is kind of an obvious thing, right? If you've got lots of cloud, then the sun can't get through. If the sun does get through, then probably you haven't got very much cloud. Next is daily maximum humidity. This one is measured it's a percentage. In other words, it's out of 100. Now, 100% means this is the maximum amount of water vapor that could be in the air. So 100% equals totally saturated air. So this is the maximum amount of water vapor that could be in the air. The thing you need to know about this is if we've got greater than 95% humidity, then there's lots of water in the air, and this is going to make it either misty or foggy. What implications is this going to have? If this is misty or foggy, then visibility is going to be impaired. So visibility will be low. Next up, we've got daily mean wind speed. Now this one's got two sections to it. It's measured in knots, KNS for short, and it's also measured with the Beaufort scale. So let me just talk through both of these. So firstly, daily mean wind speed is the average wind speed across the whole day. So knots is a continuous piece of data, can have any value within a range. And also we're given a direction of the wind speed. The Beaufort scale, this is a scale that's from 0 to 12, and each number between 0 and 12 is given a descriptor, which means that we've got qualitative data that is described using words. Now let's have a little quick look at the Beaufort scale. I've got a little table here. So you'll see for each Beaufort scale, so let's look at 2. This is the associated knot speed, and then this is the descriptor, light breeze. Or if we go stronger, let me 7, this is the knot, so it'd be up to kind of around 30, and this would be described as a near gale. So going back to my chart here, you'll notice that this is discrete data as well. Okay, it can only take certain values, it's not continuous. One more thing I want to talk about is the direction, okay? The direction of the wind speed is given in terms of a bearing, and we're given a cardinal value, which is north, south, east, west. And the bearing is from north. The other thing I want to say about wind direction is that it is a measure from where the wind comes from. So say if I've got a wind that goes from left to right like this, the direction is where it comes from. It comes from over here. So this, in terms of north, south, east, west, you might think, well, this is going to the left, to the right, so surely this is east. But that is not true. It's coming from the west. So we call this a westerly wind. Next up is daily maximum gust. Now this is the maximum gust of wind that you'd get in any one day. If you imagine a flag in the wind, it's the moment that the flag was taken up by the wind the most. This is measured in knots as well. And of course, this is also continuous, as we said before. We are also given a direction for this too. Next up, we have our trusty favorite, cloud cover. This is measured in eighths or octas. So this is eighths of the sky covered by cloud. And is this discrete or continuous? Well, this one is discrete. And why is that? Because it can only take certain values. Next, we've got visibility. Visibility is how far you can see in front of you horizontally. This is measured in decimeters, and 1 decimeter equals 10 meters. You need to remember that. So visibility is how far you can see in front of you. It's measured horizontally, and of course, if it's foggy, then visibility is going to be decreased. Also to note here that instead of NA, we have a dash if there's no data available. And finally, ladies and gentlemen, we have daily mean pressure. This is measured in hectopascals, HPA for short. This is the daily mean amount of pressure in the air. There's not a huge amount to remember for this one, except that the values are kind of like up around at the 1,000 mark, so they're all quite big numbers. And so that's all of the information that we need to learn. There's one more thing to say though, which is the international weather data stuff that we've got here. Because the international weather stations, Jacksonville, Beijing and Perth, they only have 4 pieces of data. So unlike the UK ones that have got all of these things, they only have 4 pieces of data. What are they? They are daily mean temperature, daily total rainfall, daily mean wind speed, but critically not direction, which is why I've not highlighted the direction. And finally, daily mean pressure. So those are our 4 data types that happen in the international stations. So let's fill that in. Daily mean temperature, rainfall, daily mean wind speed, and pressure. The last thing I want to say is that there seems to be quite a lot of information there, and To be fair, there is, but once you have got your head, especially around the names of the places and where they are, then a lot of this is common sense. And indeed, in these questions, you're often being asked to use common sense. So, for example, you know that a city nearer the equator is going to be hotter. So if you see two bits of data, one which has a higher mean temperature than the other, then you know that one of those places is probably going to be nearer the equator. So if it's a toss-up between Jacksonville or Leeming, then the one that's hotter probably be Jacksonville. Like I say, a lot of this is a measure of common sense, and you just need to think nice and clearly. Again, another example would be if you're given some data and it's discrete, then that data can only be one of two things, can't it? What are our two discrete pieces of data? Well, we've got the discrete Beaufort scale data for wind speed, and we've got the discrete cloud cover. And again, if that data was from an international station, then we know that cloud cover doesn't happen at the international station. So if you have some discrete data at an international station, it must be daily wind speed. I hope that's helpful. The best thing you can do from here on in, once you've learnt kind of this stuff and got familiar with it, is A, print this sheet and fill it in. Fill it in yourself without looking. B, practice some questions by topic. So practice some questions that include the large data set, okay? And there's a few questions that are attached with this video.